Math 113, Lesson 10-1. So the last video, we reviewed a circle. And a circle would be a set of points that is equidistant from one point. So the radius all the way around the circle is exactly the same. Well, an ellipse does not look like that. An ellipse looks like one of these two diagrams. Okay, it could either look like an egg that is standing up, or it could look like an egg that is laying on its side. But if you look at that, they both still have a center value, but if I drew what would be considered the radius, it is not the same length all the way around. So we cannot talk about an ellipse exactly like we talk about a circle. So in our ellipse, there are a few things that we need to talk about, and I'll just use these diagrams that I already have over here. All right, so this point is definitely our center point. And then we will have what's called a major axis. The major axis runs through the center. And these points where it actually touches are considered vertices. So each one is considered a vertex. So the major axis joins the vertices and it goes through the center. So if we draw that on this other one, our major axis would be this red line, and these would be our vertices. So each is a vertex. This point in the middle is my center, and that red line would be considered my major axis. All right, so there's the first part of an ellipse. The next part would be, there are these other 2 points that we connect. This also goes through the center, and this line is called the minor axis. Now, the major axis and the minor axis are always perpendicular to each other. All right. The endpoints that are on the ellipse join the minor axis. That's what actually forms that segment. So we would have a minor axis on this one that looks like this. Notice the major and the minor axis are always perpendicular to each other. All right, so a few things that I want us to make sure we understand. Our center is going to be H and K. Our major axis, because we have one of those now in an ellipse, has a length of 2 times A. 2 times A, that is its length. The minor axis has length 2 times B. And always in an ellipse, A squared is greater than B squared, because A is a part of the major axis, so it's always longer. So when I square A, it's definitely going to be bigger than when I square B. So let's go over here to our diagram and look at what that really looks like. If the length of this red line is 2A, then the length from the vertex to the center is A, and from the center to the other vertex is A. The length from the center to this green end point would be B, and the length from the center to the other end point would be B. So the length now, hopefully you can see, of the major axis is 2A, the minor axis is 2B. And that's true on both diagrams. So A squared is always going to be larger than B squared. So I told you what a vertex was. Let me write it down. Vertices, that's plural. They are A units from the center and they are on the major axis. So look at the diagram and convince yourself that that's really what it looks like. Vertices are A units from the center on the major axis. Now, one thing that I do not have on our diagram, those little green points don't have a name, okay? So if you're looking for a name for those, they don't have one. Something I don't have labeled on the diagram is called a foci. Now, foci is plural for focus. Each focus is C units from the center, and it is also on the major axis. And so you don't have C in our diagram that we have drawn. I don't have the focus up there, and I don't have the value C written up there. So let me use another color. I'll use blue. All right, so on our diagram, the one that we can still see, our focus is going to be somewhere on the major axis, and the distance from the focus to the center is going to be C. Now, I'm not going to draw that. There's too much going on in that diagram. But this is important. All of this information that I've drawn for you, that I've written for you here, super important moving forward. This is stuff that you're going to want to have beside you as we start working some problems. So one other piece of information about this C value is there is a correlation between our C value, A and B. And so we need to make sure we know it. C squared is always A squared minus B squared on an ellipse. Okay, that is not quite Pythagorean theorem, so please don't think of it like that. It is a minus. C squared is equal to A squared minus B squared. That's how those are related. Okay, so let's work an example. So hopefully you'll keep that information sitting right beside you to help us out. So we're going to do two things. We are going to graph and locate the foci, that is plural. And this is going to be our ellipse that we're going to use. X squared over 36 plus y squared over 9 equals 1. And it's going to be super helpful if I go back up here and write for you the equation of an ellipse. So I brought it back down just a little bit. And so our equation for an ellipse, the standard form, is x minus h squared over a squared plus y minus k squared over b squared equals 1. Now that's only one equation, because remember our ellipses could look like an egg standing or an egg laying down, and I'm going to help you figure out how do you know which one is which before we actually work that example. Okay, these equations are very similar. Notice the only difference is where the a squared and b squared are located. It's the only thing that is different here. All right, so I told you these are the two equations that are the standard form. Now, one of these equations represents an egg laying down, the other represents an egg standing up. All right? So if the egg is laying down, then that means it has a horizontal major axis, right? A horizontal major axis. That would look like this. The major axis is horizontal. Well, that would be this first equation that is directly up under that. This other equation would be a vertical major axis. So horizontal major axis is the one that's laying down. A vertical major axis is the one that is standing up. Now here's how I keep that straight in my head. we will look right here. Notice that a squared is up under the x squared. Okay, now A is on the major axis. That's why it matters where A is. A is on the major axis and it's up under the x value. X runs left and right. So the major axis is on the horizontal line. Okay, for this other one, if I look at where is A, it is up under the y value. Well, y runs up and down. So this time our major axis runs up and down. So that line, the length of it is 2a. So that's how we decide, is our ellipse laying down and have a horizontal major axis, or is our ellipse standing up with a vertical major axis? All right, so let's look at the example that I have for you here. Now, a couple of things I gave you listed above. I told you a squared is always greater than b squared. So when I look at my equation, I know right away that 36 is a squared and 9 is b squared. That's the only way I know that, is from this statement right here. Okay, so my a value is up under the x. So this is a horizontal major axis, which means it's going to look like it's laying down. Okay, for sure, it's going to be looking like it's laying down. All right, now we have to find the foci. All right, it said we had to find the foci. Whoops. Didn't know that could happen. All right, so here's our little equation. We have decided that it has a horizontal major axis. We now know a squared is 36. We know that b squared is 9. Now remember, I gave you a relationship between c squared, a squared, and b squared, and this was it. So we're going to use this to help me find what our foci are going to be. So c squared is 36 minus 9. Take the square root, and I get that my foci is the square root of 27. The square root of 27. All right. Now I have to know, what in the world am I supposed to do with that? Let's identify our center first of all. Well, if I notice, it doesn't look like I have an h and k in my equation. So that means my h value is 0 and my k value is 0. So the center here is the origin. Awesome. Now in my little list of things that I told you, I said that c units from the center is where the foci is located. So let's think for just a second. Here we have our ellipse whose center is 0, 0. We know that a squared is 36, so that means that a is 6. So I know 6 spaces to the right and 6 spaces to the left. These would be my vertices. Now, it didn't ask me for those, but it did ask me to graph, so I must know my vertices. Well, those are at 6, 0 and negative 6, 0. All right? The foci are on this major axis. So my foci are somewhere between 0 and 6 and 0 and negative 6. Well, that c value tells me where they are. Now, I don't know what the square root of 27 is, but let's simplify it. It's 3 on the square root of 3, all right, which is some number smaller than 6. I'm not going to stress over exactly where that's located. Let me whip out my calculator and I'll tell you what the decimal is, because I know that makes some of you feel better. That's about 5.2. Okay, that's not a value that we really need on our paper, but we might need it for looking at the graph. All right, so my foci are, do not use the decimal here, my foci are negative 3 on the square root of 3, 0, and positive 3 on the square root of 3, 0. Because remember, they are on the major axis. So these two are my foci, these two are my vertices. Now, the B values, which they don't have a name, they're not called vertices or foci, my B value is 3, and that's what connects my minor axis together. So this would be my ellipse. So the things that we're looking for are the ordered pair 0, 3, 0, negative 3. This is the ordered pair 6, 0, negative 6, 0, our center, and then our two foci. I don't have enough room to write them, but I did write them over here with my center and my vertices. So there it is. This is going to take a little practice, and having that list of what does C really mean? What does A really mean? How do I know if it's horizontal? How do I know if it's vertical? It's going to be helpful to have that stuff sitting beside you. Let's try another. So again, we are going to graph and locate the foci. And since we're graphing, that means we also need to know the center, the vertices, and those endpoints that join the minor axis. Okay, so when I look at this equation, that doesn't look right. That is not what the standard form of my ellipse looks like. The standard form of my ellipse should be equal to 0. Should be equal to 1. It should be equal to 1. Well, this is equal to 144. So what we're going to do is we're going to divide everything by 144. Alright, so when I divide everything by 144, I'm going to get x squared over 9 plus y squared over 16 equals 1. Now this looks like the equation of an ellipse. Alright, so my next order of business is, I know this one is a squared and this one is b squared, because remember, a squared is always bigger than b squared. So in this problem, a squared is 16, b squared is 9. Notice that my a squared is up under the y squared, so I know that this one is vertical. It has a vertical major axis. Just so that I can keep that straight in my head. Alright, so I know this one looks like it's standing up. Alright, I can find my c value. 16 minus 9. And c is the square root of 7. So now I need to know, where is the center, where are the vertices, and where are the foci. Alright, so I'm going to sketch it as we go, just so that I can keep it straight. Alright. If a squared is 16, then that means a is 4. If b squared is 9, that means that b is 3. Alright. So the center, if I look at my equation, x squared over 9 plus y squared over 16, I don't see an h and k again. That means that they are 0 and 0. So my center is 0, 0. My vertices, remember, that's a spaces from the center, and a is 4. So 4 spaces from the center, and this is a vertical major axis, so we're going to count up 1, 2, 3, 4, and then down 1, 2, 3, 4. right? Those are on the major axis. So this is a vertex, this is a vertex. So let's write those down over here. My vertices are 0, 4 and 0, -4. My foci are on the major axis, and my C value is the square root of 7, which is about 2.6. Don't really need that written on my paper, but if it helps you with graphing. So I'm going to go 2.6 up. Let me go back to, I'll use this color. And then I'll go 2.6 down from my center. Okay, not stressing about where that's located. It's about 2.6. And those are my foci. So that would be 0, square root of 7. Sorry about that. And 0, negative square root of 7. Notice I do not use a decimal there. My math lab is not going to want decimals unless it specifically asks, which I don't think it does. Okay, and the only other thing, this clearly does not look like an ellipse. I just have some dots up here. Now I do need the other endpoints of the minor axis. So I know that my B value is 3, so I go 3 spaces from the center in both directions, and that would be the vertices, the points that connect my minor axis. So here's my ellipse. We have the ordered pairs 0, 4 and 0, -4 as my vertices. I have my foci on the graph, my center, and then I did need those other points which don't have a name, they don't have a specific name, but they are the endpoints of the minor axis. So how about I write those down? Ooh. You weren't asked to actually show these, but you need them to draw your graph. So it makes sense to have them written down. The endpoints of my minor axis were 3, 0 and -3, 0. Okay, moving on. Okay, let's change up the way we ask our question. Let's find the standard form of the equation of an ellipse with foci at -2, 0 and 2, 0 and vertices at -3, 0 and 3, 0. And so this time we're asked for the equation. Now, even though I'm not asked for the graph, I'm going to graph what was given to me just so I have something to look at. It helps me out. All right, so I'm going to graph the stuff that was given to me in red. My foci are -2, 0 and 2, 0. Those are my foci. They are on the major axis. My vertices are -3, 0 and 3, 0. Those are also on the major axis. So, remember that A is the distance from the center to the vertex. So if I look at my two vertices, it's going to be important for me to know that, a little tip here, the center is midway between the vertices. and the foci for that matter. So if my vertices are at -3 and 3, then my center is right here. All right, so now I know my center is 0, 0. That's helpful. That's going to be my H and K. The other things I need in my equations are a squared and b squared. Right? Well, a squared I know. A is the distance from the center to the vertex. So in this case, a is 3. So a squared is 9. 3 squared gives me 9. Now, I don't know what b squared is, but remember, c squared is a squared minus b squared, and we know c. C is the distance from the center to the foci. So in this problem, c is 2. So c squared is 4. We know a squared is 9. I can find b squared. So if I subtract 9, divide by that -1, and then take the square root. I know that b, that is a 5, sorry guys. B is the square root of 5. Now b squared, I know, is 5. Okay, b squared is 5. Because in my equation, okay, remember that's what we're looking for, standard form. In my equation, I have x minus h squared. Okay, this one definitely has a horizontal major axis. Okay, it's important to know that because that's how I know which equation to use. Because my vertices run horizontal here. So I am using x minus h squared over a squared plus y minus k squared over b squared equals 1. That's my standard form. So the things I need to know are h and k, which I have, those are my center, a squared and b squared. So I have everything I need to plug it in. Let's simplify that just slightly because we know that when you subtract 0, it is just x here. When you subtract 0, it is just y there squared. So x squared over 9 plus y squared over 5 equals 1. And that would be our equation in standard form. That was what we were looking for. I know it seems like a lot of work to do that one thing. That's what we're looking for. All right, let's try one more. Last example. And this one is just a graph. I want us to graph this ellipse. Alright, so if I'm graphing it, then I need to know a few things. I need to know the center. I need to know the vertices. I need to know the foci. And I need to know the end points of the minor axis. So in order to find the vertices, I've got to know the value of A. In order to find the foci, I've got to know the value of C. And in order to find these endpoints, I have to know the value of B so that I can find all of these. Okay? So those are not my answers there. I just wanted to go over what would I be needing there. All right. So let's see what we can find. Remember, my center is H and K. Well, here's H, here's K. My H value is +1, my K value is -2. Take the opposite sign of what you see. It looks like -1 for H, I take +1. It looks like +2 for K, I take -2. All right, so we got that taken care of. Now I've got a 4 and a 9. Remember, A squared is always bigger than B squared. So for sure, over here to the side, I know that A squared is 9 and B squared is 4, which makes A 3 and B 2. All right, so since I know A and I know the center, I can give my vertices. Now I am going to sketch myself a little graph as I go. I mean, our whole goal here is to graph it. Okay, I may have to add a little bit to my graph. All right, so I'm going to start with putting my center on here. My center is 1, -2, not at the origin anymore. All right, there's my center. Couple of things we need to know next. First thing I need to know is this horizontal or vertical major axis? Now that, remember, we look at where the A value is, it's up under the Y. So this is a vertical major axis. A vertical major axis. So if this is my center, then my major axis is a vertical line. So if A is 3, then my first vertex is 3 spaces up and 3 spaces down for the second one from the center. So 1, 2, 3 spaces up would be my first vertex. 3 spaces down would be my next vertex. So those two ordered pairs are 1, 1 and 1, -5. All right, so we added and subtracted 3 to the Y value right here. That's how I got those values. Remember, vertical major axis. So A is the distance from the center to the vertex. So we have to count up from the center and down from the center. All right. I can go ahead and do my endpoints of my minor axis because that uses the B value. So I count from my center 2 spaces to the right, 2 spaces to the left, and these are the endpoints of my minor axis. Now they don't actually have a letter that I put on the graph. So that ordered pair is -1, -2, and 3, -2. All right, and the last thing we got to do is find our foci. Well, I can't find foci until I know the C value. My C value, C squared, is equal to A squared minus B squared. So C is the square root of 5. The square root of 5 is about 2.2. Don't really need that number other than to know where to place it on the graph. Remember, it is on the major axis. So I start at the center and I count 2.2 spaces. So 1, 2.2. This would be my foci. And then go back to the center and count down 1, 2.2 spaces would be about right there for my second foci. Whoops, I did not mean to erase that point. Sorry about that. So now I have got everything I need to draw my graph. I'm going to write down my foci points over here because you're going to have to in my math lab. All right, my foci points are what we're going to do, let me write it out like this so that you can see exactly what's happening here. The x value is not changing from the center. What I'm doing is I'm taking the y value from the center and I'm adding the square root of 5. And then I do it again, but this time I subtract the square root of 5. That's the 2 points for my foci. My math lab is going to want the exact answers like this. I don't believe it's going to allow you to put them in as decimals. So this will just take some getting used to. A big thing here is make sure you decide if it is a horizontal major axis or a vertical major axis, depending on where a squared is located in your equation. All right, let me know if you have any questions.